Hey guys, welcome back. We're starting a new unit of instruction. In fact, we are starting trigonometry. So it is 6.1. The last full unit we did was unit 4, and then we just did a little 1 week of 2 assignments, and I called that unit 5. So unit 5 is like almost non-existent. It was really the same topic as unit 4. Maybe I shouldn't have done that, but I did, and it's too late to fix it now. So we're calling this unit 6. Now, to start trigonometry, trigonometry is all about angles, and we got to learn some basics about angles. So that's what this whole week is about for the most part, starting with how to measure angles. You are probably all familiar with degrees. You may not be familiar with radians. Some of you may be, some of you maybe not. Depends on what your Algebra 2 and geometry classes were like. Well, let's talk about degrees. Almost everyone is familiar with this. A degree is a unit of measurement for an angle. There are 360 of them in a full circle. A straight line has 180 degrees. A straight line is basically half a circle. A right angle is 90 degrees. 1 degree is very, very small. So if 360 degrees fit in a circle, 1 degree would look, very, very small, sort of like that. If we took a pizza and cut it into 360 equal slices and you got 1 slice, you would not be very happy unless you already ate and you weren't hungry. But if you want pizza, 1/360th of a pizza is not much. The next unit of measurement, which you might not be familiar with, is radians. So radians is a whole different way to measure angles. And we start the explanation with a circle. What you're looking at right now, this diagram, is 1 radian. 1 radian is much larger than 1 degree. If I gave you a slice of pizza the size of 1 radian, you might be able to eat a couple, but it's a lot better than 1 degree for sure. So how to calculate a radian is you take the radius of a circle, which is, you all know, right there. Let's say you cut it out of a piece of string or thread and you lay it along the circle so that it can bend. Where it stops, connect that to the center with another radius, and the angle you get is called 1 radian. Now, the question might arise, how many radians fit in a circle? We know there's 360 degrees in a circle. How many radians are in a circle? I'm going to try something with notability. It might work. It might be a complete failure. Let's look. I'm going to copy this and then paste it. Where's paste? Wow. I'll paste image. And then I'm going to move it over and rotate and try to get all fancy schmancy. Oh, I don't want to shrink it. I just want to rotate it. All right, I practiced this earlier and it worked. So if it doesn't work now, I'm sorry. So there's 1 radian. Let me do it again. Rotate. Put it here. And what you might already notice, besides me having a little bit of a struggle here, is that's not perfect. It's off a little. Darn, I really want it to be perfect. It just won't line up. I feel like I've had it a couple of times and just not coordinated enough to make it lay right where it's supposed to lay. Maybe it's because it's rotated a little too much. But I'm going to take one last shot and then I'm going to call it good enough. Call that good enough. Okay. So what we have here is 3 radians, which almost makes half a circle. So we could say, probably based on this, if 3 radians is almost half a circle, then a full circle is almost 6 radians. And that's true. But what the half circle is actually a little more interesting to look at. Let me try to clean this up a little bit. So this is right here, and that's right there. So here's 1 radian, 2 radians, 3 radians with a little bit left over. The interesting part is that little bit left over. How much is left over? Well, here goes. So what we have is 1 half circle, which is 180 degrees, of course, is equivalent to 3 radians with a little bit left over. That little bit left over part is a decimal. It's approximately, I'm going to have to round off here, it's approximately 3.14. There's approximately 3.14 radians in 180 degrees. Now, is it exactly 3.14? No, that's rounded off. What is it exactly? Well, 3.14159. Actually, the numbers go on forever, but you should recognize by now. So this is approximately 3.14 radians. 180 degrees is equal to pi radians. So therefore, a full circle is double that. 360 degrees is 2 pi radians. And then 90 degrees would be half of that, so that's pi over 2 radians. And those are some fairly standard angles, and that's how radians work. In fact, you could argue that's where the whole pi thing comes from in the first place. So radians is a much more theoretical measurement. It's not theoretical, I mean it's real, it's right there in front of you. But when you deal with irrational numbers like pi, you start feeling, oh, it's getting really deep into the theory things. No big deal. We just use the pi symbol a lot when we measure things in radians. All right, so how big is 1 radian? A decent sized slice of pizza. That's how big 1 radian is. How many radians are in a circle? A little bit more than 6. A half circle, a little more than 3. You want to be more precise? Okay, a full circle is 2 pi, half a circle is pi, 90 degrees is pi over 2. All right, with all contrasting systems of measurement, converting from one to the other is an important skill. So take, standard and metric. How many centimeters equals how many inches, or how many pounds equals how many kilograms. And there's always some way to transfer or to change from one to another. If you're in the automotive field, engines can be measured in cubic inches or cubic centimeters or liters. So you got cubic inches like the Chevy 350, but then you could measure it, other engines are measured in cc's, usually like motorcycles, or in liters, a 5-liter engine or 5.7 liter engine, things like that. If you're in the medical field, there's cc's for, isn't there cc's? I don't know, and I'm getting a little bit out of my depth. Maybe I shouldn't go too far, but just about anything you do, temperature can be measured in Celsius or Fahrenheit. Maybe culinary, I don't know. Would you ever have a metric stove, or is it all Fahrenheit? But it's pretty typical to be able to convert. And so that's what we're doing here. We're going to talk about converting degrees to radians and radians to degrees. And there's 2 simple rules. To convert degrees to radians, you simply multiply your angle by pi over 180. So here, if 180 degrees equals pi radians, divide both sides by pi, you get a conversion factor of 180 over pi. On the other hand, if you divide both sides by 180, you get a conversion factor of pi over 180. So to convert degrees to radians, you multiply by pi over 180. Therefore, to do the opposite, radians to degrees, you multiply by, not the opposite, but the reciprocal, 180 over pi. And that's what you need to know. Now, those are fractions, so you will have to do some fraction work here. It might help to have Desmos handy. I'm going to pull it up. But when I get to the first set of exercises, convert each degree measure to radians. Basically, I need to multiply, I'll use the dot for multiply, everything by pi over 180. So let's do this. 285 degrees, we need to multiply by pi over 180. Okay, 180 degrees. Put this over 1, you multiply 285 by pi, okay, 285 pi. 1 times 180, 180. We do still technically have degrees on top and bottom. Actually, the labels can cancel. They reduce just like variables, just like numbers. So you don't need to put the degree symbol on this step. They're going to cancel. And all we got to do is simplify, simplify the fraction part. What's 285 over pi? We are not going to put 3.14 in for pi. It's not going to happen. So our answer is going to have pi in it. We just have to reduce the fraction 285 over 180. Well, if you love fractions, you can work that out on your own. If you don't love fractions, you can do this on Desmos. 285 divided by 180. Now that's a decimal, that's not a fraction, But if you hit the little circle next to it, see there where I'm pressing? You can't see me pressing it, but you can see what's happening. I get 19 over 12. This works out to be not 19 over 12, but instead 19 pi over 12. So the number's reduced, the pi is still there, and that's your answer. Now, technically we converted to radians. Oops, I'm erasing a little too much. I want to make that pi symbol look a little better. So you'd say it's 19 pi over 12 radians. You know, we always label our answer, right? You put an angle in degrees, you have to put the little degree circle there. I mean, it's required. So the answer here would be 19 pi over 12 radians. Well, let me go down and check the answer for number 2, and there it is. And you'll see the word radians is not written anywhere near it. You could see rad as an abbreviation for radians, but most of the time you actually don't see a label. And generally, if you're doing work in the context of trigonometry or angles or something like that, and you see pi, you should just assume that that means radians. So it's such a broad assumption that the label is actually almost never written into these problems. So when you do your work, you do not have to label it radians. You can just say 19 pi over 12. All right, let's do this on number 4. So convert, we need to multiply by pi over 180. That gives us 225 pi over 180. Can you reduce 225 and 180? For sure you can. You can do it by hand by dividing numbers out, or you can use a calculator. 225 over 180. Oops. Well, I got to hit the divide button, don't I? Over. Wow, I'm messing everything up. 225 over 180. And then hit the fraction button 5/4. So that's 5 pi over 4. Check the answer on number 4. Oh, negative. Look, there's a negative sign on the original problem. Yes, you can have negative angles. So if this is negative, then the answer, of course, would have to be negative. All right, let's do a couple more. Multiply by pi over 180. Tell you what, I'm just going to go ahead and do 710 over 180 and reduce that to 71/18. So it's 71 pi over 18. I guess we could have reduced that without a calculator. You know, those zeros cancel. That's a shortcut. And I'll do the next one as well, and we'll check them 2 at a time just to make things go a little faster. So we have 165 pi over 180. 165 over 180 is the fraction 11/12. So there is a negative sign here, so I'm going to do negative 11/12, but then put pi up there with the 11, so negative 11 pi over 12. Check those 2 answers, and we're doing good. So to change degrees into radians, multiply by pi over 180. That's the scale factor. That's what you multiply by. The labels sort of cancel themselves out. You don't need to worry about it. Leave pi as the pi symbol. Don't plug in 3.14. Use a calculator to help you reduce if you need to. And if your problem has a negative sign in it, be sure to put a negative sign on the answer. And that's what it boils down to. It's very, very doable math for you. The next few problems is just the opposite. We're going to convert radians into degrees. So here, we need to multiply by 180 over pi. Now, we can cancel the pi's. Pi on top, pi on bottom, they cancel out. That leaves us with 5 times 180 over 9. Well, once again, you can work fractions, in your head or whatever, or you can use a calculator. I'm going to use a calculator. 5 times 180 over 9, and this works out to be an even 100. 100 what? Well, in degrees, you do have to put the degree symbol down. You don't get the luxury of just leaving it as a blank number. So 100 degrees. Remember, the pi sort of indicates that it's radians, so we don't write radians. If it was just 100 without any label, you don't know whether it's 100 this, 100 that, or 100 something else, so you do need the degrees. 100 this, 100 that, whatever. Okay, number 12. Again, multiply by 180 over pi. The pi's cancel, so you get 180 over 4. I think that's 36. Let me check. 180 over 4, or 45. Yeah, that's why I use a calculator. I have good days where I can do stuff like this in my head, no problem. 45 degrees. Let me do another one here. Why is 14 the same as number 12? Good grief. All right, someone did not proofread their work very well. And look, your number 13 is the same as your number 11. So, yeah, call that a gift. Number 16, multiply by 180 over pi. Pi's cancel out. Gives us negative 180 over 3. I don't need a calculator for that. I know that 18 divided by 3 is 6. So 180 divided by 3 is 60. This is going to be negative 60 degrees. And am I right? Yes, I am. And that one, of course, that one's right. So when you do your assignment, 11 and 13 are the same thing. Sorry about that. Or there you go. It's a gift. Okay. So that's that, one of the very basics, first day back. Hopefully it's not too much trouble for you. If it is, of course, contact me with questions. Otherwise, get to work on this. Good luck, and I will talk to you later.